Hello, my name is Vladimir Korikov, and this is the Domain-Driven Design in Practice course. In this module, we will introduce the second bounded context in our application. Along the way, we'll discuss the differences between bounded contexts and subdomains and how they relate to each other. We will also talk about how to choose boundaries for them and how to perform context mapping. We will look at different types of physical isolation for bounded contexts, how they communicate with each other, and finally, we'll discuss the guidelines for using code between them. In the previous modules, we ended up with a snack machine model. Now we have given a new task: create another model, at this time for an automated teller machine, ATM. This model would allow the users to withdraw cash using their bank cards. Just as with the snack machine, here we'll leave aside such details as how exactly card operations are performed or how the ATM dispenses cash. Our focus area will be the business rules behind this model. So what are the requirements for this new task? First of all, the ATM must give the users cash they requested. In return, their bank card should be charged the worth of money dispensed plus a 1% fee. Also, the model must keep track of all money that was charged from clients. To solve this task, we'll introduce a new bounded context. We'll discuss the reasons for that shortly. For now, let's take a closer look at the notion of bounded context. Bounded context is a central pattern in domain-driven design. It stands for separating the model and explicitly drawing the boundaries between its pieces. The reason for such separation is that as your application grows, it becomes harder to maintain a single unified model as it becomes larger and more people get involved into the development process. Big models bring significant communication and integration overhead with them. Bounded contexts help reduce that overhead. There are several attributes that belong to the notion of bounded contexts. First of all, they act as a boundary for the ubiquitous language. It means that the language we use for communicating with domain experts and naming classes in our domain model should be consistent and unified only within a bounded context. At the same time, the naming doesn't have to be consistent across different models. Two bounded contexts can hold entities or value objects with the same name, and they can be completely unrelated to each other. That's perfectly fine. You can think of bounded contexts as if they were C# namespaces for the classes in your codebase. Two namespaces can hold any set of classes, be they intersecting or not. For example, the snack machine bounded context could have a class named composite element, which represents a replaceable item in a machine. The ATM bounded context at the same time could have its own version of that class with its own set of attributes and business rules. These classes, despite the same name, should be viewed differently as they reflect different concepts. Another important attribute of bounded contexts is that they span across all layers in the onion architecture. It means a bounded context is not something you can point out on this diagram. Each of them is represented with its own onion, so to speak. So, if you decide to introduce a new bounded context, it should have its own set of entities, repositories, factories, application services, and all other layers from the onion architecture. And finally, it's important to explicitly state the relations between bounded contexts. That's where context maps come into play. A context map is a map that renders the bounded contexts in your system and the connections between them. If you want to see an example of a context map, I recommend you to watch this talk given by Eric Evans. We will draw our own context map later in this module. There is another concept in domain-driven design, subdomain. It's important to understand the relation between subdomains and bounded contexts, as they are often mistaken by programmers. There are two central elements when it comes to building a software project: a problem and a solution. The problem is the reason why we are creating the project, the thing we aim to solve with it. The solution is the actual artifact of our efforts of trying to solve the problem. So, the differences between the two concepts is that subdomain belongs to the problem space, whereas bounded context to the solution space. In other words, a subdomain is a part of the whole problem, a part of the problem domain. A bounded context at the same time is a part of the solution for that problem. Subdomains and bounded contexts are best related to each other as one-to-one, meaning that ideally every subdomain should be covered by exactly one bounded context. It's not always possible though. Let's say, for example, that you've come to a legacy ERP project which you need to enhance to address new requirements for the sales subdomain. If the existing codebase isn't covered by automated tests, it might be scary to change it, so you might decide to add a new bounded context and separate it from the existing codebase by an anti-corruption layer. In this case, you end up with two bounded contexts that cover a single sales subdomain. It's a good practice to avoid such situations though, because the codebase is overall easier to maintain and understand if there is a strict one-to-one relation between subdomains and bounded contexts. So in the example above, there should be ideally a single sales bounded context. In our case, we have two subdomains, Snack Machine and ATM. As we are working on a greenfield project, meaning that we don't have any legacy code here, it's easy for us to adhere to the guideline and create a single bounded context for each subdomain. It's important to keep explicit boundaries between bounded contexts, but how to define them in the first place? How to draw a line between one bounded context and another? As I mentioned earlier, the best way to do that is to adhere to the one-to-one guideline. In other words, create a separate bounded context for each subdomain. So the question boils down to how to define a subdomain. A subdomain is usually not something that is defined by us, developers. As the notion of subdomain refers to the problem space, it is often defined by customers and domain experts. The boundaries for subdomains usually come up naturally during the talks with them. For example, they might mention that they want to build a sales prediction subsystem to help the company stabilize its revenue, or they want a support subsystem to decrease the expenses related to the customer support activities. All these are signs of separate subdomains, so in most situations you just need to carefully listen to the domain experts. However, this approach might not work in some cases, as you need to take into account other factors as well. The first one is the size of the team. If your subdomain is too big and that causes the team working on it to grow more than, say, 6-8 developers, it's a strong sign you need to separate the bounded context in two and form an independent team for each of them. The second factor is the size of the code. Even if your team is small enough, it might be that the code in a bounded context grows enormously so that it becomes hard to manage its complexity. In this case, you might also want to depart from the one-to-one guideline and create two bounded contexts for a single subdomain. The general rule of thumb here is that the code of a single bounded context should fit your head, meaning that you shouldn't have a lot of trouble understanding it. In my experience, though, it rarely happens and the one-to-one guideline works just fine in most situations. Alright, we discussed situations where there might be several bounded contexts for a single subdomain. But what about the opposite? Can a single bounded context cover several subdomains? For example, in our application, the Snack Machine and ATM subdomains are pretty small. Doesn't it make sense to solve those problems with a single bounded context? It's true that in our sample application there is little code in bounded contexts. For example, the Snack Machine model consists of only two aggregates. Nevertheless, even if you are able to cover two subdomains with a single bounded context and still keep it succinct, I recommend you to adhere to the guideline and still create two separate bounded contexts for them. Just make sure the subdomains they cover are indeed distinct ones and not parts of a single subdomain. The reason here is that bounded context segregation is a logical one. Whether or not to keep them separated physically is a different question. So even if you do create two bounded contexts, you don't have to create separate sets of Visual Studio projects for them right away. You can carry the code together while it's small and thus keep the maintenance overhead low. We will talk about the degrees of physical isolation for bounded contexts later in this module. The last guideline regarding boundaries for bounded contexts is how they relate to the development teams working on them. It's a good practice to keep the team's boundaries aligned with those of bounded contexts. It means that while one team may work on several bounded contexts, there shouldn't be a situation where two teams work on a single bounded context. It would lead to communication issues and increased maintenance costs. Let's draw a map for the contexts we have in our application. But before that, let's see how the structure of the ATM bounded context looks like. It will consist of a single aggregate with the ATM entity inside. As the ATM needs to dispense cash, we need to represent that cash somehow, and we already have a suitable class for that, MoneyValueObject, which we can use in the ATM entity. Another field here is the money charged field, which will indicate the amount of money charged from the client's bank cards. So now we have a situation where the same value object, MoneyValueObject, is used in both bounded contexts. That means there is a shared kernel between them. So our map goes like this. You can see the two bounded contexts use a shared kernel and don't interact with each other, so we can say there is a separate ways relation between them. That kind of relationship actually indicates no relation whatsoever. It's important to remember that such map should reflect the actual state of affairs, not the desired one. If the bounded contexts in your application interfere poorly, for example, one of them has become a big ball of mud and starts affecting other contexts, show it with such diagram. It will be a good starting point on the way to fix the situation. If you see that one of the bounded contexts decays, meaning that the code in it is a mess, you might want to protect other bounded contexts from its impact by introducing an anti-corruption layer.